here, you've been given a rectangular pyramid. Okay, so it is 10 by 10. Okay, and the height is going to be 8. Okay, so the formula we'll actually work out the volume. The volume of a pyramid, so that's how you spell pyramid. The volume of a pyramid is equal to the area of the base times height, just like with a prism. Okay, but since it comes to a point, pyramids come to a point, whereas rectangular prisms go straight up, we need to divide that by 3. We're not going to justify it right now, we're just going to use that formula. So if I'm going to find the volume of this pyramid, I need to have, it's going to be 10 by 10 times the height, which is 8, and then I'm going to divide that by 3. So I end up with 800 over 3 centimeters cubed. Okay, so if I want to reduce the volume to half, how do I keep the same shape? What's the dimensions going to be? Okay, well, if I take the half the volume, well, I need something cubed that's going to give me half. Remember the side length, the relationship between the side length and the volume is cubes, right? If I cube the side length, I'm going to end up with the volume. So to do this problem here, we could do it with numbers, and we can say that we have, side or volume of, it's going to be 800 over 6. Okay, so we want exactly half the volume. Okay, but if we understand this relationship, we know that some side s cubed should give us 1/2. Okay, half the original volume. And we could say v over 2 or 1/2 volume. So if I want to get the side length that gives me half the volume, I can just cube root this. And so I end up with the cube root of 1/2 will give me the side length of that volume. Okay, and so, in fact, I should just leave that volume out of there. That factor of cube root 1/2 is a factor that I want. Okay, so that's approximately equal to, if I cube root 1/2, it's approximately equal to punch this into my calculator here. The cube root of 1/2 is about 0.793. So I'm going to use 3 decimals for a bit more accuracy. 0.794. Okay, so it's 39. So if I use that as my factor, about 79.4% of all those dimensions, we're going to get exactly half the volume, which is this one that we're looking for here. So my new volume is going to be based on 79.4% of 10, so 7.94 times 7.94. Okay, and then I'm going to take that length or height of 8 and times that by that same 79.4%, and I get 6.35 about. Okay, and I'm going to take that volume and divide it by 3. Now I'm going to get about the same answers here. Let's get the decimal answer here first. It's going to be 800 divided by 6, which is about 133.3 cubes. Okay, so if I work this out, hopefully I get the same thing. 7.94 times 7.94 times 6.35 divided by 3, I'm getting 133.44. And the difference is from the rounding. Okay, because when we take the square root, this number is not exact. So if I wanted to work out the side length from the volume, I have to take the cube root. Okay, and there's this relationship. So I'm going to write this relationship. If I take the side length to area, we square. If I want to go from area to side length, I square root. Okay. Now, if I want to go to volume, the volume is slightly different. I want to go to volume by cubing, and I want to go from volume to cube the side length by cube rooting. So if I take half the volume here, and right there is, if I take the half the volume, if I want to figure out the factor for the side length, I just cube root. Same with area. If I want to take half the area, I need to square root that to get that. Okay, so this relationship is very useful. Okay, we're going to see this relationship later on, and this really helps us understand how we can go from things like surface areas or areas to volumes to side lengths and back and forth between them. Okay, so here it says surface area is reduced to half the surface area but keeps the same shape. What are the dimensions? So I want to find the side length when I have half the surface area. Okay, so this is where we can use this concept. So I have a surface area, that's 1/2. If I want to go to side length, I can follow that, and I'm going to square root. So I know that the square root is going to represent the factor change of the surface area, of the side length, not the surface area, the side length. So if I want to find the new dimensions, I'm going to use that factor, which is approximately 0.707. So my new dimensions ends up being 7.07. That's my width. 7.07 is my height. Actually, I should write that slightly differently. The base is 7.07 by 7.07, and the height is going to be that same 70% of the height. So 7.07 times 8 is going to give me 5.66. The height is 5.66. Okay, and this will give me 1/2 the area, or in this case, the surface area.